case it might help other folks. But so we have a trinomial, you see? And I say factor, you say greatest common factor always anyway, and there isn't anything in common because this is 2a's AA and this is a bunch of stuff and it doesn't apply. And then you say, what is it? Oh, it's a trinomial. And a leading coefficient is 1, meaning it's a simple trinomial. So you simply open, close, A, A. And then since this has to be a b squared, let's go ahead and put a b and a b. Okay, so this might have caused some confusion because I didn't even think about these the other day. Well, I always say, bring me problems so I can work them for you. Okay, and then we have a product and a sum. And the product is 56 and the sum is negative 15. Yes? So that's what we do. And then we play around here until we come up with the numbers that when you multiply them, you get 56. When you add or subtract them, or when you sum them up, you get a negative 15. So an 8 and a 7, do you guys agree that if you borrow $8, you borrow $7, you owe 15, and 8 times 7 is 56, and negative times negative is positive. So then you simply put that in there, and it doesn't matter which one you place where, and then you check it by FOIL, and it will work. Oh, I guess, Tristan, I'm wrong. 6-2 is next week, and this is really 6-2. So you're 6-1 at the end of this week. That's just GCF and factoring by grouping, which we did a couple of those the other day, and I'm happy to do more. So, oh, how are we doing? Did that help? Yeah, it's the mixed variables that I didn't think about them. Okay, so anything else that you bringing in, and then if not, I'll keep looking through here and seeing if I can help you come up with some. And Tristan, I double checked in the final exam module. And so you scroll all the way down, and the final exam module has in it a video on long division, which is the hardest one for students. So it's at the end of chapter 5. So if that helps, that should help you if you're interested. So, okay, any other questions right now? Everything's crystal clear. So we got an auto factor. And you guys weren't doing the weird ones yet, right? Just the simple trinomials through this week, I think. But I'm happy to get ahead. And next week is going to be a little tough, especially for my 110 folks, because they have to catch up with the 112 people. So for 112, this is a little bit, you know, like everything's spread out real nice. So let me clear this. Now, we did some the other day that started with something that isn't a 1x squared. Do you want me to work this one, or do you want me to wait? Would it help? And there's one other factoring sheet I can bring up that we can work. Maybe I'll bring one up that's a little more basic. Maybe this is the one factoring summary worksheet. So let's look one more time. So this is a 4-term, and you double bubble. We did that the other day. Let's just look at these. Oh, see, this is the second one, so there isn't much. Let's look at this one. Did we do something like this the other day? So you say it's a simple trinomial. You simply open, close, Z, Z, and then you had to do your thing. Did we do this one? Probably. Product -3, sum is 2, and you have to come up with numbers. And really, when you have a 3, you only have one option. It's a 1 and a 3. And then you have to decide which one's negative to give you the +2. So this has to be a -1 and a +3. And then you check by FOIL. Yes? So, I mean, if you don't ask, I'm just going to keep going, and I hope I'm not boring you to tears. You need to say something. Okay, so this is a trinomial. that isn't simple. Whoops. So this one here is going to be a little hefty even for me right now because I'm looking at it and I shouldn't be looking at it too far into it. It's never a good idea. Okay. This is first of all, before I ask, is it a trinomial, binomial, what is it? I look at this and I say factor, you say greatest common factor. Most important question you'll ever ask. So is there GCF? And then you're gonna say no. And why am I doing this? Let me make one up real quick. You see how on this one here, we would have said it doesn't have a GCF, so you go over the top, remember this? And then I'm going to go ahead and go into this one, but I'm going to show you one because I think it's important. Now, what is 15 times 8? So I'm intimidated right now because I don't feel like digging out a calculator, and I'm in front of you guys, not 20 people, but just 3, but still. But then I know that 10 times 8 is 80, and half that is 40, so it must be 120. You know, so that's how I kind of think about it. And then my 22 is right here. Now, I already know the numbers because once you do that, sometimes it's just really obvious, other times it's not. But 120, if you take 120, and some people don't know how to do this, you know, you can say, well, that's 1 times 120. That would be great if this in the middle were a 121 or 119, for example. But that's never going to work. So then you say, okay, 2 times 60 is 120. You see how you're still not going to get there. That would be great if this middle one was a 62. So then you keep fiddling with it. But a lot of times when you see one with that ends in a 0, maybe we should just try a 10 and a 12. You know what I'm saying? Right? So try to make it easy. It's not always going to be easy. Some of them are really weird where you need a calculator and you have to take try a bunch of combinations, but this 10 times 12 is 120, 10 plus 12 is hopefully 22. And then I take the middle and I split them, right? So then I leave the first one. I split the middle into 2. This is what we did the other day. So should I put the 12 near the 8 or the 10 near the 8, or it doesn't really matter in this case because the 15 and the 10 have something in common, but the 15 and the 12 also have something in common. So which one would you like for me to put where? Because it doesn't matter to me. Would you put the 10 with the 15 probably, right? And then you will always, this stays here, so you don't change the first or the last, you split the middle, and then you double check and say 10 plus 12 is 22 true. And these have to have X's because you're combining like terms to go back up here. And then you say, okay, great, I have 4 terms, I'm gonna double bubble. So that's what we do here. And here you have in the first bubble, you have in common, they both have a 5 and they both have an X. And then 5X times what is 15X squared? How are you doing? Too fast, too slow? You're taking notes, so I feel like we're at an okay pace. I don't want to just ramble on and you can't catch up. And then 5X times 3X, 15X squared, true. 5X times what is 10X? 2, yes? And then last time we said, hey, put that plus down here because you should always bring a sign down. And then you say, what do these two have in common? You see how there's a 2 in common, but it's not going to work. So play with this. You know, if you grab the 2 by accident, 2 times what is 12, 6X. If this doesn't match that one, you have a problem anyway. So you want to pull the greatest common factor. So you're going to pull a 4, yes? And you can always check. Now, some people pull a 4X. There's no X in the 8. You can't pull an X, okay? You can only pull something that these 2 terms have in common, and that happens to be the 4. And then you open and say 4 times what is 12X? 3X. 4 times what is 8? So some people just copy this one down. That's not going to fly either. You want to make sure that you check your work as you go all the time. 4 times 3X, 12X, true. 4 times 2 is 8, true. And now these 2 things match. these two big terms have something in common. It happens to be a binomial. So I wrote down the steps last time. I'm not going to do it again this time. But you pull the GCF. So then you pull the greatest common binomial factor forward. And then I guess last time I didn't record. I just don't know. If you watch my video, I show all these types. So I really struggle with making this public. Because then in the future I'll accidentally use it, and I don't know. So why is this here the biggest deal? This here is the biggest deal. So here, let me show you something. I want to show you something because we need to compare. So let's say we have something like this. So I'm just making this up right now, okay? So what some students do is they immediately look at this and say, it doesn't start with a 1, so I'm gonna go over the top. Can you see where they might be doing that? Like this is what happens. And in this case, it's a little more obvious, but I'm gonna do this wrong now. So I don't want you to write it down, okay? So some people say, I'm going to go over the top, and then they have a 48 and they have a 14, and then they play with this. What is that anyway? 8 and 6, right? So then they go through this whole process, but I got to show you why it's not going to work. Let me put it doesn't matter, 8x plus 6x plus 24. I need to show you what's going to happen when you do that. So I'm going to do this fast because you're not writing this down. That's not true. It is true, it's just not right. And then these two match. And then students think, hey, it even checks. Think about this. If you foil this, you do go back here. If you foil this one, you have to be able to go back to the top. The problem, what is the problem with this? It's not completely factored. And this is why I don't want you to ever start it out that way. So what happened? Do you see how this here is not completely factored because these two things have a 2 in common? So don't do that. But I do need to bring it up because people do it all the time, and then they're like, oh, I probably did it because you confused me and you showed it to me. I'm like, no, even when I don't show it, people do this. Okay, you always ask GCF, and then you look at this and say, hey, they do all have a 2. And you pull the 2 and you open and say 2 times what is 2x squared? 2 times what is 14x? And 2 times what is 24? Yes? So this is really critical. If you pull the GCF all the time, you're so much better off. And then look at this. This is now inside is a simple trinomial, and you don't even have to go over the top, and you don't even have to waste your time with double bubble. All you do is you say, oh, this is a simple trinomial. Open, close, open, close. Don't forget this too. This is part of your final answer. And then you do your trinomial here, where you say, oh, my product is 12 and my sum is 7, and I'm going to use a 3 and a 4. You see? So please, please hold that, keep that in mind all the time. It's so critical. Students, even students that are good at factoring, mess this up a lot. Always pull the GCF, which is why this is my factoring summary, but why I'm pretty sure I have it in your shell at the end. Pretty sure I have it in your shell. But look. You see, and I mean that this is the most important one, step 1. Yes? So keep that in mind. Okay, so those of you who are doing, even those of you who are caught up in 112, You're not doing special items yet. Are you doing binomials already this week? Or have you looked at the homework? So we dealt with a simple trinomial. We dealt with an over-the-top trinomial. This is a binomial. You see this? And this is the stuff that yelling for more graham crackers. This is a binomial, and then you have to know a formula. So is that in your stuff this week, or do you want to go this far, or would you rather go and do it next week, or what do you want me to do? Those of you who are here, because you're, this is your time.
I'm okay if we walk ahead.
Okay, you don't mind looking it over. Okay, so we can do at least the difference of squares, because the trinomial, well, Markeisha wanted some of these, but I think she was more interested in she said repeated or completely. So they can get a little more involved. Okay, so if it's a binomial, do you see how it's binomial? So first you still ask, is there a GCF? You still ask that first GCF, and then you say no, because that's a 5 and a 5 and an X and an X. And then you ask how many terms. So this would be the second thing you do. It's a binomial. And then you're going to say, is it a difference of squares? Whoops. This is not pretty. And that means, this is how it goes. A squared minus B squared is A plus B times A minus B. So I like to show chapter 5 and then relate it to chapter 6. So back when, I don't know where this green came from. It's not even the color I picked, whatever. Back when you might have had, it's hung up on the green, x plus 3 times x minus 3, and I'm just making this up, but this might be something in chapter 5. In chapter 5 you were multiplying, and then you FOIL this, and you get an x squared minus a 3x plus a 3x minus a 9. And then these two, I borrow $3, I pay back $3, they cancel, and you're left with an x squared minus 9. And back then I would have said, if you had me in class, I would have said, okay, you don't have to memorize a formula, this formula in forward, because you can always FOIL. You see how here you can FOIL. But in reverse, you're going to have to learn the formula because you can't fix it otherwise. So if you have a difference, this is a difference of something squared and something squared, and this is an A is X, so I label them actually. But this is, you ask what squared is X squared? Oh, X. And what squared is 9? And you say 3. And when we're dealing with formulas, you don't worry about plus minus. You worry about what is the individual piece. So you ask what squared is 9, and that's a 3. And then you say, if you're going forward and you're supposed to factor this, you're going to say, oh, x squared minus 9, a is x, b is 3, and a squared minus b squared is a plus b times a minus b. So, but you absolutely have to know that formula. Difference of squares. Now be careful that it's a difference. I'm going to tell you this, a squared plus b squared, this is a sum of squares, is prime, meaning you cannot factor it. So later when you want to factor that, you have to remember you cannot factor in a sum of squares because it will never check by FOIL. It just won't. Hold on. So if I ask you to factor this one, could you? And I don't know why it's so weird. I think it's using, oh, see the green pen, it's using my word. But you can see this, right? This isn't me writing like the other day and you can't see anything I'm doing. Please tell me you can see this. Okay. Because I was working in the snip the other day and it didn't show. This is Word, so I think it does show because I'm sitting here talking and doing. And okay, so you're going to look at this. You're going to say, is there GCF? No. Then you say it's a binomial. Is it a difference of squares? This is a difference, meaning subtraction. Yes. Something squared, what would that something be? Don't all yell at once. Kind of sucks for you when there's only 3 people on the spot. If there's 30 in the class, nobody, they can all kind of duck down and hide. There's always that one that wants to give me all the answers all the time. So don't be shy now.
5 squared equals 25.
So what squared would be 25x squared? You would say a 5 and an x. You see it? Because 5x quantity squared is 25x squared. So this inside here would be your a, you see? And then you ask, what squared? So I'm going to label it because I'm going to call it A and B because I need to stay organized. They're going to get a little messy at times. Now, what squared would give you 36y squared? So now that we're warmed up.
6.
Yes, 6, and you need a y squared, so you're going to do a y, yes? And then you're going to say a squared minus b squared is a plus b times a minus b. And then you can check it by FOIL. And when you FOIL them, the outer and the inner always cancel if it's properly done. Cake. These, usually people like these. These are fun. Until we get into repeated factorization, they get messy. So let me know if I can move on or whenever. I think you're still taking notes, so I'm gonna make sure. I'm gonna have a little coffee. Coffee at night helps me sleep. I'm just kidding. Can I erase it? Yeah, okay. No, I cleared all drawings, you see, and the green stuff is gone because I used the word. I think I'm gonna have to manually erase this whole thing, or I can do it like this, I think. Nope. Oh, oh, interesting. Everything is weird. Oh my word. I don't have time for this. Whatever, you stay. Okay, now let's look at this one. Oh, get over here. Now, what would you do with this one? If you had to. So usually what I do in the classroom, we do the last one, and then we get here, and people mess with this. And then I get 2 different answers depending on the folks.
Is it 2x squared minus 64?
So if you do it this way now, hold off on taking notes, okay? But the way you're doing it, if you're doing it 2x squared, then you're gonna have a 2x squared here, yes? Because this times this has to be that. Now, what about the 64? What do these 2 have to be? So you would have an 8 and an 8, wouldn't you?
Yeah.
And hold off, don't write this down. And then you're gonna have a plus and a minus, true?
Yeah.
And then when you FOIL it, you're gonna have a 4x squared minus 16x squared, or 4x to the 4th, sorry, that's my fault. And then plus a 16x squared. and then a minus 64, and then you combine these and they disappear, and then you argue with me, why is this incorrect? This is not correct. Why is it not correct? Because you see how the 2 and the 8 have something in common? Yeah. So this is where, don't do that. We're learning right now, and that's completely normal. You learn the most when you make these mistakes, but step 1 is always not, is it a difference of squares? Do I use a formula? Is it a simple trinomial? What's step 1? Remember? So step 1 is always GCF. So you would say, hey, there's a 4 inside of here and a 4 inside of there, and then you open it. So hang on, let me show the problem. 4x to the 4th minus 64. So the first thing you ask is there GCF? Yes, there's a 4. Then you say 4 times what is x to the 4th? 4 times what is negative 64? You see it so far? And then you ask, am I done? And then you say, can I continue factoring? The thing in the front's done. But this piece here then is an a squared minus a b squared. So a would be your x squared, like you had the right x squared. You just didn't pull the GCF first. And b, what would b be if b squared is 16? I know that always sounds funny. 4. So then you say, okay, you have your 4. And then you say a plus b and a minus b. And probably Markeisha would really benefit from this one. So I have it recorded, and I will go ahead and make a YouTube thing out of it, because this will help. And I'll just tell her to look for that number 5. Okay, now, so here you ask, am I done? No, because you had a difference of squares. Yes? Inside here. And then here you're going to ask, am I done? And this is critical. Here you have to ask, am I done? And a 4 is a 4. The computer won't take it 2 times 2. What do you do with well, this one here is a difference, sum squared, sum squared. Then this one is a what? A sum of squares. So here's the thing. I have a lot of students, I'm going to do it in red, and they do the following. They say, well, I'm going to take that x squared plus 4 and make that x plus 2x minus 2. And then I'm going to take the other one and make it x plus 2x minus 2. This will not check, because this piece here is never going to be x squared plus 4. Because when you FOIL, you see how you're going to get a negative 4. And it can't both be, and then they say, well, it's both pluses, and it's not, because if you think about it, if you FOIL, you're going to get x squared plus 2x plus another 2x plus 4. So you get a 4x here. It doesn't disappear. So what did I tell you earlier? If you have a sum of squares, it's prime. You see what I'm saying? Like this piece is prime. Not the whole thing, but this piece is prime. So you're going to bring down that 4. You're going to say, I'm going to leave that thing alone because she's telling me to. In the classroom, we do so many of these that I threaten with the fly swatter, you know, but it's really hard to do this fun stuff in the Zoom. And then you say, oh, this is a difference of squares. And yes, I will factor this one, you see, because this is going to turn into that a plus b. A in this case is x, and b in this case is a 2. So you have different a's and b's depending on which line you're in. So what you ask, what squared is x squared? Oh, x. What squared is 4? Oh, 2. And then you have your plus minus. And yes, some people put a minus plus. You know, a squared minus b squared is a plus b times a minus b. Or a squared minus b squared is a minus b. Some people were trained with the minus first. You see, it doesn't matter because of commutative property, 2 times 3 is 3 times 2. But I like to always put my plus first because that plus 1 here is done. this is done, and then I just focus on the last piece. So personally, I like this better. Now I'm going to ask, am I done? So this is where Markeisha said, hey, factoring completely, you know, that's a little tricky. Now this is completely factored because nothing else is factorable. This is done. So there's your final answer. And you see how over here, if you did it like this on the left and accidentally did the 2, you could still factor. You could continue and you could say, hey, these have a 2 in common, so I'm going to pull the 2. And then you're going to say, I'm going to pull that 2. There's no plus. And then you would have 2 times 2 is that 4. And the x squared minus 4 is factored into this piece. Still always better to do this. So that was a forever long way to explain one problem, but I like to really get in depth because I want you to understand it, not just, you know, the computer videos are great, but then it's harder for you to really put this stuff together, I think, you know. So hopefully this is beneficial. How are we doing? Super fun on a Friday night. Oh, I see a chat. Okay, I understand, Carrie. I have a kid. He's been staying up till 8:30. It's terrible. We're terrible parents. I'll put it in there. I doubt very many people watch it, but I'll make it available. Thank you for coming. So Tristan and Chase, now you're on this spot. Let's look, because I don't want to make this super long. I've also been told, well, if you make Zoom recordings, make them 15 minutes long. I'm like, I can't do that in 15 minutes. And every time I do that, I have to go to YouTube and upload them, and that's a pain. But I don't want to do number 6 right now because that's special. Let's do that next week. So maybe Chase, I mean, you like to come to these. Maybe you'll remind me that I need to do number 6, or I'll just keep in my mind that I'll cover that. But let's look at number 8 real quick. This is something that you'll need sooner anyway. And this is where I say factor, you say greatest common factor. Is there one? And then you say no, because 8 is a bunch of 2s. And then you might say, okay, so I can't, and I'm not allowed to just open, close, open, close. I mean, you can doing trial and error, but the rest of us are going to do it this way because it works for everyone. Trial and error people, they're special. They just make it happen. So we're going to say, okay, it's one of those over the top. And then you do a product, and remember the sign is critical. So 8 times 7 and -9 is -72. And then the sum is a 6. And then you play with values, and 72. Why am I stuck right now? 12 and 6. 6 times 10 is 60. 6 times 2 is 12, right? 72. And then maybe a positive 12 and a -6. You see how you just have to play with it. Sometimes it takes you longer to come up with it. Worst case scenario, you say 72, and don't worry about the signs right now, but 2 times 36, never going to get you near 6, trash. And then you do 72 is divisible by 3. 3 times, I don't know. Oh yeah, that's 3 times, I don't know. 24. And then you say that doesn't get you close to 6, trash. And then you do 4, 5, 6, and then you finally get there. You know, but you have a calculator, you can take that stuff apart. And then what do? You keep this guy, you keep that guy, and then you split the middle into what you found right here, these 2. Sometimes it matters which one you put where. And then we check our work and make sure these 2, and I know my Z's are not everybody's favorite, but these just are. But these 2 combine into that one. And then you have 4 terms. What do? Double bubble. So, and the more you do this, the easier it gets, because you just get comfortable and you're practicing and you're just like, oh, I've done this before. What do they have in common? A 2, but also a 4. And they both have a Z. 4Z times what? And 4Z times what? You know how many months I had to practice Z to be able to pronounce it, and it's still bad. 3, and then you open. And this is where people make mistakes. -3 times what is -6z to z? And -3 times what is -9? And this is where people do that minus, they bring that down, and you have to be careful, you pulled a negative here. So -3 times what is -9? +3. And you see how now they match. So people will accidentally put a negative down and then they don't match. So, oh, I don't like writing 2 next to the z. That's why I'm probably doing this. And then the leftover goes in here, and then you check your work by FOIL. See? Not terrible. Factoring by grouping always works. Trial and error, some people struggle with it. So I'd rather be safe than sorry. And then we'll do one more and then we're cooked, or what? Or we're just having so much fun we don't want it to end. Did either one of you bring one that you want me to work? Oh, there's one that looks ugly. So here's one. Would you, now, so a bunch of people in my classroom, they'll go 12 times 30, and I'm like, terrible idea. What do you do? Right? Critical. You always pull a GCF. Sometimes you get lucky and it turns the rest of it into a simple trinomial. This time I don't think we're so lucky. So what do these have in common? 2, there's the 6, and the 6. Is there a 6 in 54? Yes. Okay. You see it? Open. And we'll check it. 6 times what? 2y squared. 6 times 9. Basic math is not always my friend. I'll just be honest. 6 times -5. This has to be practiced. And then you look at this. If they still have something in common, you didn't pull enough. You know, some people just pull a 2 or they just pull a 3. If you just pulled a 3, look at this. You see, these all have a 2 still. There's a 2 in here, a 2 in here, and a 2 in here. So if you accidentally don't pull something big enough, you should be able to catch it. And then you say, am I done? No. Now you ask, can I factor this piece? And now this is unfortunately an over the top. So some people like to use a bracket here to make it look a little easier until the end. And you would do this over the top. And you say your product is -10 and your sum is 9. And then it's a 10 and a -1. Right? 10 times -1 is -10. 10 minus 1 is a 9. So the thing here is that people forget this in the end. They'll factor this trinomial and forget this in the end. So I usually suggest you do it like this and bring that down as a bracket. And then you're going to do your thing, just like you did earlier. You're going to split the middle, and you're going to leave the first and the last. I'm going to put, don't hate me, but I'm going to put the -y first. I want that 10 near the 5, but it doesn't matter. It'll work either way. -y plus 10y, or -1y, right, is 9y true. Double check your signs. And then you double bubble this. And then you're going to say y times 2y minus 1 plus 5 times 2y minus 1. Don't forget the 6, you see. And then you have a common binomial factor. You pull that forward. Put your leftovers. These are your leftovers. And you don't forget your 6. The computer will not want a bracket on top of everything else. So you just have to, at this point, go get away from the bracket. How are we doing? Getting easier? Yeah. And then the next one, I'm just going to start it so that if you ever see something that looks, you see how it looks really weird with those exponents. So people freak out over that one. The first step really gives them trouble, but I'm not going to finish it. So I'm going to say, okay, I say factor, you say greatest common factor. Is there one? And hopefully you're going to say yes. there isn't a number greatest common factor, but there's an m here, and there's an m squared and an m cubed. The most m's you have in any one of them, or the least, like they all at least have one m, yes? And then you say, well, what is up with the n's? There's an n cubed, an n to the fourth, and an n to the fifth. So you're going to have to pull an n cubed. You see it? Because they all have an n cubed inside. And then you open, say 27. M times what is m cubed? M squared. And do you see how the n's disappear on that first term? That's actually really good. And then minus. You just got to let that stuff happen. There's a 6. M times what is m squared? M. And n cubed times what is n to the fourth? N. I might have to finish it just because I'm interested in it now. Yeah, I'm invested. Now, I know that some of this will still give you trouble. Mn cubed times what is mn to the fifth? So you can't put an m, there's a minus, because there's already one here and one here. So n squared, you see it? And I probably should have pulled this over, gone ahead and scrolled it down, but I didn't. So if this were just an m squared, I could just open, close, and squeeze it, but I can't really. This is for the trinomial. I'm going to do the trinomial over here, and then I'm going to bring the answer of that back. So trinomial, leading coefficient not 1. So we're going to split the middle. And we have to deal with that. I don't know what's going to happen yet to that. Yes? So we're going to do product. And this is where people struggle. What is my product over the top? Yes? And this is a 1 really, isn't it? So it's 27 times negative 1. Don't worry about the ends. So negative 27. What is my sum? Negative 6. And then I'm going to say a 9 and a 3, and it's really not that intimidating once you see that. So you have a negative 9 and a positive 3. I'm going to put, which one do I want where? It doesn't really matter. I'm going to do the negative 9. Now what goes here? You see, this is a little weird for people. If this says mn, this has to be mn. Because when you combine these two, this is like borrow $9, pay back $3, and you owe $6. And now you have 4 terms, you double bubble. And then from each term, bubble, you pull the greatest common factor. So in this 2, they both have a 9, and they both have an m. Hold on. Boring? If it's weird or we're okay, I'm just checking. I only have Chase's communication. Tristan's leaving me hanging. 9m times 3m, so I'm going to assume we're okay. I don't want to put you on the spot. I know that's uncomfortable. 9m's times negative, and then you'll say, that's what I get for coming in here and making an effort. I get picked on. I don't want that either. Plus, what do they have in common? An n. N times 3m is 3mn, and n times what is negative n squared, you see? And now these two match. So if you just trust the process and do the same thing every time, you will never have a problem. It's just this one looks a little weird. So then actually I'm going to come over here because I'm too lazy. And I'm going to bring that GCF right there into my final answer. So that's about as ugly as it gets for the trinomials leading coefficient not 1 for now. So hopefully that helped. I'm going to, it's on videotape. I'm going to go ahead and upload it, and then you can watch this again and fast forward and whatever you need to do if you need it, if you want it, if I went too fast. So let me just check with I'm going to clear the drawings if that's okay. And I'm going to check real quick what else is on here. There's probably, we already did the difference of squares. So the only thing we haven't covered is like number 6. And here's another one that's repeated factorization, number 10. Do you want me to do it so it's done? Or do you want me to forget about it? It won't take long if I do it, and we'll still be done within a total of an hour. But
I'm okay with either or.
you okay with going over it? Or did you
Yeah.
say, okay, happy to do it. Okay, so let's do it. This one here. Oops, I got the word again. That's okay. Okay, I say factor. You say greatest common factor. Yes? So what you're not going to do is say, oh, a must be 3x squared. That's not what you do. You say, is there GCF? So then you say, oh, yeah, there's a 9 in both of them. You see it? 9 times x to the 4th? Yes. 9 times what is negative 9? 1. And then you say, well, what is this? Is it a difference? Yes. Something squared? Yes. And then something squared. And this is a little bit weird for people, but 1 squared is 1, right? And then you say, okay, now I'm gonna bring that 9 down, because I always bring that greatest common factor down with it. And then I'm gonna factor this into a difference of squares, which is a plus b times a minus b. And then you say, am I done? That depends. Don't force it. You know, if this one x minus 1, you wouldn't factor it, but it's an x squared minus 1. So this is another difference of sum squared and sum squared. What do you do with the sum of squares? Nothing. You leave that thing alone. What do you do with this? Nothing. You just leave it. So you're going to leave the first 2, and then you're going to say this is a difference of something squared and something squared. Open, close, a plus b, a minus b. And then you look at it and say, am I done? Well, this is a difference of something squared? No. And so this is your final answer. See, factored completely. That's the key word, that everything should be factored completely, not just factored. So, yes, I appreciate you guys coming in here and spending your Friday evening. So I was thinking next week, I wrote myself a note when I wanted to do it. It's not on a Friday. I think it's going to be Wednesday, if that's okay. So I was thinking, where's my list? I don't know, but I will send it out, and then you'd show up whenever you want, or send me questions from homework. And, you know, like, or tonight if you're doing homework, or tomorrow if you're doing homework, anything you think that, man, I wish I'd seen something similar, or another explanation, just send it to me. I don't get a lot of emails. I get some emails from the same people all the time, but a lot of people are very quiet in the homework. So just ask so I can clarify. Yes? So have a fun weekend and a good Friday night, and communicate. Thanks for coming.
All right. Bye.
Bye.